Hello, this is Mrs. J, and welcome to my math class. We're starting on the second part of Module 8, which is working with increasing and decreasing. And when you want to look at increasing and decreasing, you want to go from left to right. And so we're going down to begin with, from A to B, and it's asking from A to B. So from A to B, it's decreasing. So you would click decreasing. And then from B to C, it's increasing. So you're going just like you would read from left to right. So this one would be increasing. And then C and D, notice it's not changing, it's constant. And then from D to E, it's increasing again because it's going up. Writing an equation of a function after a vertical and horizontal translation. Okay, so remember when you're moving right and left, it's opposites of the sign. Up and down is same as the sign. Excuse me. So we've done the graphs. Now we're going to work backwards. So we know the graph is f of x equals -1/2 So we need to see if we need to put something here and here. Now notice that we are moving 1, 2, 3 to the right. So we moved right 3. That would be opposite sign, so -3. If we find the vertex, it moved right 3 and up 2. So here we took the opposite sign, so it would be a -3. Here we took the same sign, so it's +2. And that would be your equation. Let's try one more. Okay. -x² is our base graph. So we need to find these two. Now remember, if it doesn't shift one of the ways, then you wouldn't need that. You just omit that spot. But on this one, if we look at our vertex, it went -3, -2. Now when we took this value, it was opposite sign, so it's going to be a +3. This was same sign, so it's going to be a -2. And that's all that's to those. Okay, evaluating piecewise functions. First one, -3. So you want to see which one it falls into. If x equals 2, we use this. If it does not equal 2, we use this one. And -3 does not equal 2, so we use the top one. 1/4 times -3 minus 1. So this would be -3/4 minus 1, which is a -7/4. F of 2 equals 2, and so your answer is 2. And then f of 5, again 5 does not equal 2, so it's this one. 1/4 times 5 minus 1. And 1/4 times 5 is 5/4 minus 1 is 1/4. And so that's all that's to those ones. Just see where it goes and then plug it in. For each of the graphs, select the symmetries. Now, symmetries means how it can flip on an axis. There's X, Y, and then there's also origin. Origin is when it flips on the diagonal. For the first one, notice the circle. It will flip on, if we flipped it on the Y, you'd still have the same graph. What you could do is even think of folding it in half. Because if we fold it in half, they're laying on top of each other. But you're just spinning it on the y-axis. It would spin this way, on the x this way. So it definitely has both of those. And then the origin, you could turn it upside down, and if you have the same graph, then it has origin. So this circle has all three. Next one's a parabola. Now, if we flipped it on the x-axis, then it would be going down. So it does not have x-axis symmetry. But if we flip it on the y, notice if you fold it on top of each other, it's the same graph. So it does have y-axis. And then for origin, turn it upside down. Well, then we have a graph going down. So it only has y-axis symmetry. And this one, okay, so notice if we flip it on the x, then this one will be down here, this one will be up here, not the same. If we switch it on the y, notice this bump would be here then, instead of here. So it doesn't work on the y. And then try turning it upside down. If we turn it upside down, we have the same graph. So it does have origin. So this one would be only the origin. Let's try one more of those since I wasn't showing. Okay, for the first one, the circle, it has all three because if we flip it across here, it's the same. That's the y. Flipping it here, we would have the same graph, and turning it upside down, you still have the same graph. No, that's not always the case if it's not the center's not the origin. This one was only y-axis because when we flip it on the y, it's the same. But if we flip it down, then it's going downward. And if we turn it upside down, it's going down. So it only has y-axis. Where this one, if we flip it on the x, then this part would be here. So they're not the same. Flipping it on the y, then this one also comes down here and up. So it's not the same. But notice this graph, if we turn it upside down, it's still the same graph, so it does have origin. Let's try it for those other ones. So looking at this one, you can see if we flip it on the X, we have the same graph. But if we flip it on the Y, it's here. So it doesn't have Y. And if we take the graph and turn it upside down, it's now pointing the wrong way. So that one only has x-axis. The oval, same as the circle, if we flip it on the x, it will be the same. If we flip it on the y, it will be the same. And if you turn your paper upside down, it will be the same. So this has all three. This one, if we flip on the y, then it's going to be over here. So it doesn't have y. If we flip it on the x, bringing this down and this one up, again, it's not the same. But if you turn your paper upside down, you will have the same graph. So it is origin, because if we take this and then turn it upside down, there's still, oops, wait, I drew the opposite. This one is x cubed, and this one is x cubed, well, a negative x cubed, because it's decreasing. Either one, when you flip it, it's the same graph. So they have origin. Okay, matching parent graphs. I don't know if it's going to let me click on them. Okay, so this one is a cubic graph. So it would be x cubed. This one is a v, so it's an absolute value. This one is linear, so it's a straight line. And this one is a function with an x in the denominator. I'm not sure how specific they're going to be, so I want to look at the explanation so we can see the examples. Following graphs. Okay, so we're looking at these. So it is just the basic graphs. So if we look at the cubic one, they just want x cubed right here. The absolute value one, they want this. The one you need to be careful, this one is a straight line, this is a square root. This is the horizontal line as the function equals a number. These two we haven't gotten covered yet. This is 1 over x, and this is x squared. So the one they're showing in part B would be that, 1 over x. Because we hadn't covered those yet. The other one's absolute value, the function equals x or y equals x. And this one's a cubic. Let's look at one more. There we go. So this is when it equals f of x equals x. This is the absolute value. I'm going to give us the same ones. Almost. This is the parabola. So this one is x squared. And this one is 1 over x squared. X squared makes everything positive. That's why both of these are above. And so does absolute value. Okay. Come on. There we go. Okay, graphing a piecewise function. It's just like graphing the regular lines. You just have to break off part of it. For instance, you use the line 5x minus 4 up until you get to 1 because it wants less than or equal to 1. And so when we go to graph it, we know our, when I graph it, when these are like this, then instead of using my slope and my y-intercept, which you could use, we know the slope is at 1, 2, 3, 4, -4 is the y-intercept, and then the slope is 5, up 1, 2, 3, 4, 5, and over 1. And it would be this line. But we only want, if you look over here, where x is less than or equal to 1. So we want from here over. So we don't want this part. We only want here over. So graph it lightly or graph it a dotted line and then make the part you want to keep solid. If we look in the next one, it's for x greater than 1. And it goes up 4. And then the slope is down 1 over 1. So this is our line. But we want everything greater than 1, so we're starting at 1, not including it, and then this way. So then this part would not be included. And this is an open circle. Now they might want you to put this endpoint, so to find it you just plug it in to the equation. So this one was the 0.11. It might ask for that point. And then on the test though, you could do it the way we just did it. For the other one, it was -1 plus 4. So we went 1 and up 3. Is the function continuous? To be continuous, you can trace it with a pencil and never lift it up. And if I trace this, when I get here, there's a break in the line. So it is not continuous. And the point it's not continuous at is x equals 1. So it's not continuous at 1. They're not asking that right here, but I'm sure it'll come up. Let's try another one. So we have -x plus 4 and 2x plus 1, both straight lines again. If we look at the first one, or the top one, the y-intercept is at 4, and then we go down 1 and over 1. So it would be this. Now look at the if part. It says if x is less than 1. So less than 1 would be from 1 over, but not including the 1. So at the 1 we'd have an open circle, and then we want everything less than. And the other part, erase. Because we just wanted less than. On the other one, we want greater than or equal to 1, and our y-intercept is 1. So we're starting here, and we're going up 2 and over 1. So from 1 we go up 2 and over 1. We're hitting the same point. And then we're drawing our line, dotted. Now this wanted everything greater than or equal to, so that colors it in, and it goes this way. And so then it's everything greater than or equal to 1, and so this other part would be erased. And that would be our graph. And notice because that open circle got colored in, it makes it continuous. So this is a continuous graph. Let's see what else. Translating the graph of a parabola, 2 steps. Okay. These ones we already did earlier in this section. I'm not sure. I think before they made you do them with plotting the points, and now you can just shift them. But we have our graph. And if we look at y equals x plus 2 squared minus 5. Inside the parentheses, it moves right or left opposite of the sign, so it's going to move left 2, and then the same sign on the outside, so down 5. You're moving from the vertex left 2, down 5. And then you just draw your graph. So what they'll have you do is take the vertex and hold, I think you just hold it and then you slide over 2, well left 2, and down 5. And then it'll draw it. And I think these are just parabolas. Yeah. So this one, opposite of the sign, is going to move left 4. Same as the sign for the outside, moves up 1. So it would move left 4, up 1, and it would be right there. One more. Okay, this one, inside moves right or left, opposite of the sign, so it's going to move right 2. And then the plus 3 moves it up 3. So this vertex will move right 2 and up 3. These use the same rules. So this one is going to move, oh, we might need the, just in case. So if we look at this one, the 3 moves opposite of the sign, so it's going to move left 3 and down 2. But that 1/2 is going to change it. Let's see how they want you to show that. Okay, you mark stretch or shrink. Yeah, when you're shrinking it, you're going to multiply your y-axis by 1/2. So we're moving left 3, so -3, up 2. But then that 1/2 is going to change. Oh, they're finding the second point, that's why. Because it's moving here. You're moving left 3. Oh, they're doing them all in different steps. Okay, so they're breaking it into parts. You're first moving left 3. Then you want to, the normal graph would hit up here at -2, 1. And so they want you to shrink it. In order to shrink it, you're changing the y value. So you take the point -2, 1, and you multiply it by your a, which is 1/2. So -2 times the 1 times 1/2 is 1/2. So they're just getting that second point and shrinking it. And then after that, they're going to move it down 2. So then you take this whole graph and move it down 2. Now on a test, you just have to move left 3 down 2. I'm not as concerned about how precise this point is, but you will have to do it for these. So take the point -2, 1, and then whatever's in front, you multiply the y value by it. Let's try another one. So we have x squared. We know a negative in front makes it go down. So the first thing, move it down. And then the +3 makes it move left 3 and down 1. So 1, 2, 3, left 3, down 1. And that negative in the front makes it flip down. And always flip first. So it moved left 3, down 1, and it's flipped down. Okay. And this one, it's going to move to the right 2. And remember, it's a cubic function, looks like a snake. So it's moving to the right 2. That negative is going to flip it. So let's move right. And we need to flip. So the basic graph, instead of going up, is going down because of that flip. And then it's moving right 2. So it's going to start here. But you need to find out how narrow or wide it's going to be. The 3 is greater than 1, so it's going to grow faster. So it will be narrower. And to find out how much, we take, see the point 1, 1, just multiply it by 3. So instead of being 1, 1, it's going to be, well, we flipped it. Instead of being the 1, 1 here, it's going to go over 1 and go down 3. And then here over 1, instead of going up 1, it's going to go up 3. So it's going to grow faster. Okay. So these are similar to the other ones we were doing, only now instead of having just linear equations, we have the other ones mixed in with it. In this one, we have a parabola. Okay, so for the first one, it's between -4 and 4. Now we know we have a parabola. And the parabola is going up because the x squared is positive, but that -10 on the outside moves it down 10. 4, 6, 8, 10. So the parabola is starting here and it looks something like this. But we only want it from -4 to 4. In between there. Now, if we're not sure where that value is, we could plug it in. So 16, it would be at 6. So my graph's a little off. Just move my 4s out. So at -4, it's at 6. And notice it's including the -4. So it would start here and be colored in. At 4, we also get 6. So at 4, it's up here at 6. But this one, if you notice over here, it did not have the equal to. So we wanted including -4, but not including the 4. So this would be our graph. And then for x greater than or equal to 4, we use -x plus 10. Now we could graph it. We know it's a straight line, so you might as well pick this endpoint where x is greater than or equal to 4. So we plug in 4, we get 6. So the one point is 4, 6. And it's including it because it's colored in. And then our slope was -1, so we go down 1 over 1, and there's our line. So when you have a straight line, you can find the end point and then do your slope from there. Try another one. Okay, for this one, there's 3 parts. And notice one of them is a constant, so that will be a horizontal line there. Actually, it's just a point because it has equal to, but we have a parabola and we have a straight line. First one then is a parabola. X is squared and it's positive in front, so it's going upward. And then the +1 is moving our parabola from the origin up 1. So this is our graph. Now we want the parabola for x less than 1. So here at 1. So we want to find out what this point is. I'll plug it in. 1 squared plus 1 is 2. So the point is 1, 2. Right here, 2. And it's not equal to, it's an open circle. And we want everything less than it, so we're going this way and erasing this part. And then the next one says when x equals 1, the function's at 2. So it's 1, 2. That color's in that open circle. And the last one says when it's greater than 1, we use 8 minus 3x. We'll plug 1 in, and you get 5. So we're starting at the point 1, 5, 2, 3, 4, 5, up here. And we're not including it because over here it had an open, it didn't have the equal to. So we need an open circle. Our slope is a -3. So go down 2, 3, and over 1. And there's our graph. And it does ask if it is continuous. This one would not be continuous because of the break here. where this one would be because the open circle we had was colored in and it made it continuous. So this one would be continuous and this one would not. Oops, unit 1 popped up again. Oh, come on. There we go. Okay. So these ones were flipping things. The negative on the outside flips it on the x-axis. So where this is hitting -4 here, it will hit -4 up here. So think of it as flipping. So where that -4 is, we'd have -4 up here. 1, 2, 3, 4 right here. And then this point here at 4, -5, and then it's going to move up here to the +5. And this one here at -4, -3, it's going to move up to the +3. And that would be a flip on the x-axis. Now think about it. If you folded that in half, it would lay right on top of this. So it was here, here, and here. And if we folded this in half, it would lay on top of it. It's flipping on the x. When it's inside like this, it flips on the y. So we have it up at the 2. And it's going to stay there because we're flipping on the y. The other one goes up to the 4. Notice it's 2, 4. Here. No one said it's going to be over here, -2, 4. And then the other one goes 6 and down 1. Oh, 7 actually. And down 1. So it's going to go 3, 4, 5, 6, 7. So at 6 it hit here, so it'll be here. And at -7 it hit at -1. Just like that. So what you're doing when it's on the outside, looks like this. So it's switching the sign on the x. When it's on the inside, then it's x equals, whoops, xy is x -y. Yeah, they want you to graph it. So they're just giving you a few points and then you plug in the opposite signs, kind of like I did. I found those main points where the two stayed the same and then this one switched to this one because you were just changing the one value. But see how this flipped on the Y and this one flipped on the X. And then the origin is if both of them are negative. And so then X, Y becomes a negative X, a negative Y. Let's look at one more. So this one's flipping on the X. So this down here at -4 will move up to +4. This one up here at 4 moves down to -4. Just flips. This will stay where it's at because that's the axis we're flipping on. This one we're flipping on the Y. So this point here at 4 moves over here at -4. This one at -4 moves over to +4. And this one at 7 moves to -7. It just flips. See how it flipped? And then this one flipped. So you just take the point and then move it here. So these ones, they want us to move them, and then in some places we're making them bigger. So you want to multiply by 2 and then move it up 3. Do they just... So they're taking the graph. We'll first graph y equals 2g. So when you're taking the factor, you're just changing your y values. So if you have 0, 0, it's not going to change. And here also the 0, it's not going to change. But this -4, when you multiply it by the 2, it's going to become a -8. So you want to take your endpoints and make them multiples of this value, only the y value. So then notice it stretched it. It made this longer. So you take your 3 points, and whatever the value is in front that you're multiplying, it will change only the y value by that multiple. So the zeros didn't change because 0 times 2 is 0. Just this one changed. And then the +3 moves all these points up 3. So you move this one up 3, this one up 3, and the last one. This one moves up 3. So stretch first and then move it up, down, right, left. Now the next one doesn't stretch, it just flips. That negative makes it flip. And this is on the inside, so this moves it opposite of the sign, right 4. I like the blue colors. So first then we'll move it. So we're going to move it right 4. So they took this and moved everything over 4. And then the negative makes it flip on the x-axis, and that's why this flipped up and this one flipped up like that. It just, instead of being at -4, +4, instead of at -2, +2. So we move it first and then we flip it on the x-axis. Oops. Okay, testing for symmetry. When you're checking for symmetry, put in negative x and y, and if you get the same values back, then it has x-axis symmetry. For y-axis, x-axis flips here, flips down. It's this one. Because it's flipping across, it's changing the x value for the y. And origin is both of them. So if we look at this problem here, oh, those are powers. They looked weird. For x-axis, you're putting a negative in to see if it'll flip. They're actually showing you the graph, but you don't need the graph to do it. So if we take x equals y to the fourth minus y squared minus 7. To check x-axis symmetry, you want to plug in a negative in the y's position. So we're putting in negative y to the fourth minus negative y squared minus 7. A negative to the fourth is a positive. So this is y to the fourth minus a negative squared is a positive. So it's y squared minus 7. And this is the original. So it has x-axis symmetry. To check y-axis, you plug in the negative and the x. So if we put a negative here, we are not getting the same thing. So this would be no. And the last one, we plug it into both. Negative x equals negative y to the fourth minus negative y squared minus 7. Well, we already said that that makes these two positive, but this one stays negative. So we'd have y to the fourth minus y squared minus 7, which because of this negative, it does not have origin. Okay, this one. So if we try x-axis, we plug in negative y. X equals negative y squared minus 7. Negative squared is positive. So you get the original back. So this would be yes, it has x-axis symmetry. And then for y-axis symmetry, we plug in the negative and the x. Notice it does not. So it doesn't become the same as before. It doesn't have it. And then the origin, plug in negative x and negative y. So we have negative x equals negative y squared minus 7. Negative y squared becomes a positive y squared minus 7, which does not give us the original, so this would also be no. And so you have to do that for all three. So both of them had x-axis and nothing else. Whoops, wrong. Okay, now we did increasing and decreasing. This is just writing it in interval notation. So let me bring the... So you're just writing it in an interval. We have increasing and decreasing. We look at the beginning one, it's increasing. And what you're doing is you're using the x-axis. So from negative 7 until negative 4, it's increasing. And then from negative 4 to negative 3, it decreases. Then it increases again from negative 3. It increases until 1. And make sure you're using your x values. So negative 3 to 1. And then from 1 until 3, it decreases. And lastly, from 3 until 5, it increases. And so you're just rewriting them in interval notation. And finding max and mins. Okay, so let me see how they want you to write it. Usually, so it just wants the all values of what h has a local min 0 and 4. A local max negative 2 and 2. The local min occur at 0, negative 2, and 4, negative 2. Okay, so it wants the y values. Most of the time you put the y value at the x value, but it just wants just the mins. That's why I'm getting confused. Okay, so it just wants the mins. We have mins here and here. A min has to have it has to be decreasing and then increasing. A max has to be increasing and then decreasing. So these two are mins, and they are at the x values 0 and 4. The minimum value, the y, is the negative 2. Usually you keep the points together, so this is a little different. Let's try another one. So this one, they want us to find the maximums. Okay, notice there's only one high value here because it has increasing, decreasing. These have arrows, so they're not maximums. There is a maximum here. All the values at which the function has a local maximum. This one's the x value, and that would be at 1. The function, the y value, is negative 1. So this is your x value, this is your y value. There's a max at 1, negative 1. So this is 1, this one's negative 1. Try another one. Again, we want maximums. This time there's two maximums. The values at which h has a maximum would be at -2 and 2. So at -2 and 2. The maximum value is 4. Try one more. Find the value where there's a min. Well, a parabola has, if it's going up, it has one min. And so the local min is at -2. So this would be -2. The value of the function is 4. So this would be 4. And that is everything from modules 8 and 9.